We're going to be using chords today in 10-3, and then we'll also look at 10-4 together, but I will do a 10-3 separate than a 10-4. So the first thing, we got to talk about some theorems here. Congruent corresponding chords theorem. Arc AB is congruent to arc CD, therefore the chords AB and CD are congruent. I'm not so concerned that you know the specifics of this. I'm more or less wanting you to apply this information. Same thing with these next two. Perpendicular chord bisector theorem. If EG, which is your diameter, is perpendicular to DF, a chord DF, then HD is congruent to HF, aka you're splitting that in half. Then we have arc GD is congruent to arc GF. Our perpendicular chord bisector converse is just the reverse of this, since it's the converse. If you have a perpendicular bisector of that chord, then we have a diameter. So again, just applying that information. Example 1, determine the value of X. So we have a perpendicular, we have a diameter, therefore that chord is split in half. If my pen would write, X equals 8. Equidistant chords theorem. If you have chord AB is congruent to chord CD, then a line EF is equal to EG, and because they're perpendicular, so you want the shortest distance from the line to the center to make that perpendicular. So looking at this, still just applying that information, we see that EF and HG are both 16, therefore AQ and QB are going to be the same length. This question actually is incorrect a little bit. We'll discuss it further here. So I got to solve for X. Subtract off my 4X. Now, here's the deal with this. X does equal 3, but they want the length of the radius. So I'm going to actually draw a picture up here. EF is 16. This Q to A. So if I plug 3 in there, I got 4 times 3 plus 3, which is 15. They're wanting to know the radius. Well, you then have to apply that information. So this isn't, it's not shown, but you have to know that a radius, remember, is from the center to the edge of that circle. So we found the value of X, subbed it in to find the value of QA, or you could go QB, doesn't really matter, which is 15. So if I know this is a right triangle, I have then a right triangle in which I can use Pythagorean theorem. Now here's the deal. That length on that leg is not 16. It's cut in half, it's 8. So Pythagorean theorem, we have 8 squared plus 15 squared equals our radius squared. This ends up being 17, I know it's a Pythagorean triple, sorry. But Pythagorean theorem go through. So looking at that, our radius is 17. So kind of tricky to see, but it's just the fact that you can move that radius around the circle and fit it to your needs. So we had to figure out the value of X first and then move it around. So that's 10-3 in a nutshell. It's just applying those different theorems.